Okay, here we have a problem with a vector we've been given, a force vector in this case, and we want to divide it into perpendicular components. We want to find the components of this vector. How do we do that? All right, well, we start by recognizing the direction of the components that we want to get. This vector, first of all, notice in the upper left here we have the standard weather vane of north and east, and this vector I would describe as being a force vector of 30 newtons, and the direction I've been given here is 55 degrees. My reference line is east. I would ask you to figure out how I would describe that direction, and I would describe that direction as 55 degrees north of east. All right, and I want to find the components of this force vector in the east and north direction. Okay, how do I do this? Well, I start by essentially saying that force vector is the hypotenuse of a right triangle, and I want to draw in the legs of that triangle. So the first thing I do is say I want to have one vector, one component, one leg of this triangle is going to be pointing along this line that I've drawn that points east, and the other one is going to go straight up from there to the top of the vector. So I'm basically going to drop a reference line here that points north-south, and I drew it through the tip of the vector straight down so it intersects with my reference line that points east. Now I can, as carefully as I can, draw in these vector components. Again, basically drawing in the legs of this right triangle. There's one, here's the other one. So I've now made this into a right triangle with the original vector as a hypotenuse, and I've got to put arrowheads on these components that describe the direction of the original vector. This force vector is pointing kind of northeast, so it's pointing east and north. I want these components then to point east. First one on the bottom, I put an arrowhead pointing east, and the other one pointing north, like so. And then I'm going to give them names, the components of this vector. The one that points east, I'm just going to call it F because this is a force vector with a subscript E for east. And the other one is an F because it's a force vector with a subscript N for north. All right. If I want to make this look more like math class, I can give these sides names that are related to this 55-degree angle in here. The north component over here is the opposite side of the triangle. The east component is the adjacent side. And the original vector is the hypotenuse. So if I want to refer to formulas for math class, that's where those sides are. Okay, so now I'm going to do two calculations. One to find the north component, one to find the east component. I'll do the east component first. It doesn't really matter. And I have to use a trigonometry formula with cosine or sine. In this case, it will be cosine because look at the values that I know. This angle here, this 55 degrees, is what we call theta. It's just the variable name for angles. So I've got theta, I've got the hypotenuse is 30 newtons, and I'm looking for the adjacent side. So a formula that has, if I were to arc this out, for instance, I know theta is 55 degrees. I know the hypotenuse is 30 newtons, and I'm looking for the adjacent side. That might help me pick a formula. That would be cosine of theta is adjacent over hypotenuse. Cosine has theta adjacent hypotenuse. I am going to turn this into more of a physics formula by simply renaming, instead of adjacent hypotenuse, I'm going to put in the names for the physics terms for the names for these legs of the triangle. The adjacent side is the east component, Fe, and the hypotenuse is the original force, F. Then, before I put numbers in, I want a Sifu for Fe. This is pretty straightforward. I'm going to just multiply both sides by F. So I'm going to get Fe is F times cosine theta. Again, I did that by multiplying each side by F. And they cancel over here. All right. Now I'm ready to actually calculate the component, put in the values. Some things to be careful of. The hypotenuse F is 30 newtons, as I've said in class. It's easy to get into the sort of math mood where you just put numbers in. This is physics, and so they need the correct units. Also, the angle theta is 55 degrees. Please do not forget that unit symbol. That's as important as all the rest of them. Hate to lose credit for that. All right, now the actual calculation. 30 newtons times cosine of 50. So I'm going to find the cosine of, 55 degrees and multiply that by 30, and I get an answer of 17.2. I'll put 17.2. It would be perfectly fine just to say 17. And that has units of newtons. Okay, there's the east component is 17 newtons. To find the other component, at this time I could use the Pythagorean theorem or any of the other trig formulas. I'll use sine, because that's a perfectly good one to use. Sine of theta is opposite over hypotenuse. I'll show you that I don't have to put in the physics terms. I'm looking for the opposite side. So I'm going to Sifu and do hypotenuse times sine of theta. If you're putting in the physics terms for these, that would be Fn equals F times sine theta. Either one of these would be fine. And so let's plug in the values. The hypotenuse is 30 newtons times sine of 55 degrees. And I get the north component, or the opposite side, is sine of 55 times 30 degrees. Punch it on the calculator, and I get 24.6. Or I could just write 25. It's 24.57, blah, blah, blah. I round that up to 24.6, or I could round up to 25 newtons. I'm done, and I'm happy. Thank you very much.